Hey guys, hey ladies and gentlemen, thank you for coming to today's call. Actually, today's call is going to be quite interesting because I'm not going to be doing most of the call, and it's actually going to be Peter who's going to be walking you through certain progress and that's been made, and actually sharing his screen as well. Hey, Peter, do you hear me? Just wanted to make sure, just wanted to kind of do a quick sound check and make sure that everybody hears me. Just give me a quick
Yes,
yes.
I hear you. Do you hear me?
All right. Hey, Peter, how are you doing today? How's
I'm
everything
I'm
in
do I'm doing fine. I'm doing fine. Thank you. How are you?
Yeah, so I'm excited to dive into this because it's going to be pretty cool. So for everyone, just FYI, it's going to be a very technical session. So get ready. Make sure you're paying attention because I think you'll see some pretty cool things. But what we've been working on over the past couple of weeks, and actually some new ideas that have emerged and that we've crafted. And I'm really excited about Peter leading the session up because he's led up also some of these ideas and been the mastermind and the architect behind them. So, Peter, if you want to go ahead and jump into it, then I will let you do that. And let's go ahead. I'll let you take it away.
Okay, let's start, guys. Welcome, ladies and gentlemen. So I'm gonna go in for two things on today's webinar. So I will show you a little bit on the inside of the Ethereum alarm clock protocol and how we get there. So a little bit of the story behind that. As well, we go on Ethereum alarm clock JS client that our team has built over last weeks. And let's start. Okay, so first thing is a slide that depicts how the Ethereum alarm clock works. So as you probably know, there is no way to schedule the transactions on Ethereum, meaning that whenever you want to send a transaction on some time in the future, you need to be present, next to your computer. You need to send the transaction from there. So Ethereum alarm clock is a protocol created by Piper, who is actually now working in Ethereum Foundation that solves the problem. You probably already heard about that on the previous webinars. This is something that shows you how does this work. So if we go through the arrows, numbered arrows means the ordered actions on this protocol. So you as an Ethereum user wants to schedule a future transaction. So you provide the destination address to which the transaction will be sent, time of the execution. So either this is a block or daytime of the execution, amount to send, as well as the bounty. So a bounty is a is a amount of Ether currently that incentivize the people who are the execution agents. So you see them here on the right side. So basically the protocol works like that you send the transaction to the smart contract, the new contract is being created and then awaits for someone to execute it. And obviously that's the economics of that is based on the crypto economics. Works like that. If you incentivize someone to do that, there is a chance or it's gonna be executed finally. So people basically by acting as an executing agent, they are able to earn Ether or earn bounties if they are able to execute it. So that's how the flow works. So we basically creating a future transaction. This transaction is being deployed on the Ethereum network, and then when the time comes, the executing agent, so many different executing agents are able to execute it. And if that succeed and you executed the transaction, you basically get the bounty that was attached to this future transaction. So um, how we basically kind of get there. So, does anyone was on DEFCON 3 in Cancun last year? Please send me some ones into the chat. So,
Let's
I
see if
see.
anyone was. I don't think anyone was from our group.
Yeah, so yeah, me
And
neither
maybe
actually. So yeah, so how we basically, we have this kind of situation that we were able to get one ticket for our developer BJ for DEFCON 3, and that was really crazy. So he needed to decide like in a couple of hours whether he's going or not, and finally he get there, and he met with Piper, who is the creator of the protocol, and they basically had a chance to sit down, brainstorm, and uh, you know just get some thinking around how this could look like and what could be improved and so on. So what you see now is basically the kind of the work note from that meeting, and it's probably not so readable. That's why we created a better version for that. So let me explain a couple of the things here. So, for example, you see this timeline here that have some different ranges like claim window, freeze window, guaranteed exclusivity, and execution window. Why basically that complicated? Because as you might actually know that the first thing so could be very trivial implementation, like you set the transaction to the network saying on which block it should be executed, right? And then the executing agents, they just scan the network and see, and at any given time they execute it. But unfortunately, this kind of trivial implementation doesn't work, because one of the problems here is, if you want to execute the transaction, you need to pay the Ethereum fee, the cost for the transaction, your transaction that you're executing. And that means if there is like one pending transaction, the one future transaction to be executed, and there is like 10 different executors trying to get it, then the probability of you getting this transaction is something like 10%, right? And that's really a problem, because if you are 1 out of 10 times can execute the transaction, but 10 out of 10 times you pay the gas for the execution, then you basically making this business not profitable actually. So that's kind of the problem here. So Piper actually figure the way how to improve it. So he created a claiming mechanism, which means that each of the future transaction can have the claiming window and deposit that is might be required. And because of doing that, there is a better basically payout scheme for bounties, because the claiming window is spread over the time, and also there is a payout modifier, which basically incentivize people to get to claim at the end of the window claim. So if you kind of add all these ingredients, the payout will be better. I mean, the probability of you getting this transaction to be executed is higher. So it's a little bit probably complicated, but that's something that also we're working to improve, because it's
but
not. Yeah.
Yeah, Peter, you just wanted to kind of jump in and just like you said, I mean, the gist of it is that it's a tiny bit complicated, but it has been well thought through, of course, until it's actually in action, and we get feedback, user feedback, It's when different things are going to be ironed out. But these little nuances have been thought of as well. Go ahead, Peter.
Yeah, exactly. So, okay, so I think that's, because on high level, how does this work is, if you are the executing agent, we call it actually the time node. I will explain you a little bit later what's the idea behind that. But you are acting as some sort of a miner for the network. So you are always there. By using the client that we created, you can set up the client and it will automatically execute the pending transactions, the transactions that are awaiting. So let me now jump to the part where we are going to
And just quickly, Kenny was asking, and I think it's quite relevant. How is the bounty amount defined?
Okay, so the bounty amount is something that you are defining as a person who is scheduling the transaction. And obviously, the more bounty you provide, the greater chance that your transaction will be executed on time. So this is actually very similar to the mechanism that is already, is used on Ethereum. So the more gas price you provide, the chance of being executed earlier is, higher. That's how this market is going to work. So obviously there will be like if there will be a great demand for the executors, then the price will go up. And if there will be more executors than the schedulers or the people who wants to schedule the transaction, the price of the bounty, the bounty amount will be lower probably. Okay, so there is a question, where does the day token come into the picture? So yes, we will get to that in a few seconds. And let me now go on the Ethereum JS client that we created. So you actually will learn how to set up the client, and in the future, by using this, potentially become an executing agent or the time node for that. So, okay, what we need, so how we actually we always publishing the newest version on NPM. Is a tool that you get the libraries and tools and so on and so forth. So in order to install it, you just type -g EAC.js. So I obviously have already a version installed. So we kind of, if you do that, just try to follow me. Don't worry if you lost somewhere in the time. We will record that as well, publish the tutorial at the end of the webinar. So there is a question from Brendan. Late to the party, is the covering time nodes yet? Well, not quite yet. So I'm gonna discuss that at the end of the webinar. So stay with us, please. Okay, so we have the EAC.js client up and running now. So what we need, and I already put on Slack, is that we need a local node. So I will run the parity node on Kovan network and unlock my account. So I'm just going to execute it. It's gonna probably sync in few seconds. Okay, let's go. So what we can do with the tool is that we can do both things. So we can schedule the transaction to the network as well as become a executor node. So what I'm going to do now is to run my client in a mode of the executing agent. So we type EAC.js, which is the name of our program, and -c, which means -client. So I just run it, and it will detect that we are running the local node. So that's the account that has been unlocked on my node, and as well as show you the balance of your, test ether on the network, right? And What we are going to do now is to type .start, which means that we are start to actively scanning the network, right? Since there is nothing yet scheduled probably on the Kovan network, not too many people using that obviously, and that's the test network. I'm going to run the same client. So typing ac.js with -s, which means schedule, and --block. That means that will choose, because the client can both schedule in the future transaction at any block number, so that's more exact in that terms, as well as the time. So we are going to run it with a -s -s and --block. So here we are going to provide a parameters for the scheduler. So first thing, as you saw also on the diagram before, is the recipient address. And for the purpose of this webinar, I will just keep hitting enter. You can do that as well. So that will fill in the default values for you. So let's just go. And the call data is if you execute the smart contract, you provide the call data. So Ethereum knows that you are willing to execute the smart contract. So by default, it's going to be empty. The call gas, so this is the gas that is you as an executor wants your future transaction to be executed. Call value is a amount of Ether that you want to send to the recipient address, either the smart contract like ICO, for instance, or someone else, like you want to schedule a payment to your friend or a employee or whatever. You can enter the value here. The window size, so that's the size of the execution window, and that means that the window can be either short or larger. If the larger window, then the deviation of the exact execution might be higher. And the window start.
So for the window, right? Basically, the time between which it can be executed, and
yeah.
If it then goes outside of that and it hasn't happened, it just won't happen and it'll fail.
Exactly. So now we're kind of operating here in the blocks, but you can operate in a time. So if we would enter the window start at, let's say, in 1 hour, and then the window size we will put like 5 minutes. That means that we allowing the executing agent to execute this transaction within the 5 minutes of time. We can also set like 1 minute or something like that if we want to be more precise. But basically, the bigger window, the more chance you have for the execution, because the more time that if there is no executors on the network at that time, might be greater chance if the window is greater. So yes, the gas price for current transaction, and the fee amount, which is a fee to the protocol. Bounty, so if you want to set up the bounty, so we want to set up a bounty like whatever. If you send like 100 Ether, maybe the bounty, because you want to get it there and right and on time, so you might want to put bounty like whatever, 1 Ether or something like that, up to you. Next thing is enter required claim deposit, so we just go it through. So these are all default numbers, so we are going to send a scheduled transaction that is going to send to the address you see above, and the total amount of Ether and value that we need to send with this transaction is shown here, which is like 0.1590 and so on. So we now pressing enter or Y, and then we see that our transaction has been mined. So we can basically check by, so we see both things. So we have like the transaction hash and the address of the new contract. We can find it obviously on Kovan Etherscan. So you see that exact number here. Can compare that this smart contract gets the number of Ether that has been sent. So this both contains the bounty as well as number of the value that is going to be sent to the destination address. All right, so we schedule the transaction. Let me know if you were able to do that as well. Please put some one on chat, maybe. Once you schedule a transaction, can it be modified later? That's a question from Stan. Well, no, you can't. You can't modify the transaction when it's going to schedule. Actually, you can cancel the transaction and reschedule it. Okay, I see Kenny managed to schedule the transaction. So might be that our MyNode will execute it. In order to monitor that, I will run the the tail command, which just start looking into the log. So the log is by default written to our home page. So let me get rid of that. So okay, we can actually also, so we probably should get the information here that that our transaction is being executed. We need to wait a little bit because we are scheduling the transaction for a while. And okay, bingo, I think we have something scheduled executed. So you see that the transaction request at this one has there is attempt to execute it, and we are able to execute. So I'm not sure if that's mine transaction or Kenny's. Let us see. Okay, that was mine. So this transaction number, and here we see that again our executing node has executed the transaction on time. We can obviously go through the details here, see that there is a amount that has been sent to the destination address. There is also the fee donation of the fee that's sent to the Ethereum protocol, as well as the bounty. So it basically works like that. There is a question, will this presentation be available for replay? Yes, it's gonna be available for replay. I will post you the YouTube address where you can find it. Okay, the Alexander says that if you don't provide enough, you miss that time relevant transaction if nobody picks. Yes, it's possible. Obviously, we think that this is going to be attractive to the people who will act as executing agents, and it's going to be a rare situation that you will miss the time. Obviously, you will be able, and with help, because we are building a dApp to make this much easier than using the JS client. It's very raw, as you see, and yes, we are going to make it even better by adding some suggestions for the prices and for bounties and so on. So I hope you enjoy.
Just like you said, everything is very raw at this point and at this moment, but still wanted to show everyone. Go ahead, Peter.
Ooh. Okay, yes, exactly. So this is early stage of our development, and we are able now to, in a very rough way, schedule and execute the transactions. But we do believe that by enabling the dApp and deploying the dApp and making it available, we make this much more popular, and obviously it's gonna be, in our eyes, it's gonna be success. So I'm gonna give you a sneak peek here of the current development. So we are building a dApp where you will be able to schedule your transactions. So it's obviously now scaled a little bit up just for the better visibility, but you here just can see how much easier it's gonna to be. So you will be able to provide the time zone, the transaction date, time, the execution window, and so on, all the necessary information, as well as bounty and deposit and so on. So we want this to be very trivial thing to do, not like it is today. So we obviously started working on that pretty recently. And yes, as soon as we get something that is good for the release or preview and so on, we will let you know, obviously. And then yes, so we can schedule and do the transactions. So let me now just give you a sneak peek and preview on the time nodes, because what we are planning to build is to basically bring the functionality of the JS client, so being able to execute in background into the browsers. So we want to bring this functionality into the browser, which means that you will be able to set up the wallet and fund it and so on, and just leave it open. And in background, you will effectively start mining those transactions. And obviously, by doing that, you will be able to earn some Ether. And we are planning to make the time node functionality available only for the DAI token holders. We actually have much more ideas how to utilize and put DAI token into the picture, but that's really something in works, and we will try and we will reveal that later on.
Yeah, and there's basically a lot of brainstorming happening right now. So I see a lot of the questions are around that. And if we're not directly answering, apologies, but just know that that's the stage that it's at.
Exactly, and we have a statement from Gustavo that this can be used for the smart contract for loan. Yes, totally. So as you may feel that we are, as a chronology, going through the field of time-related things, and that smart contract, especially the interest calculation, is such a thing. So yes, we are going to integrate and make the integration to the protocol much easier and available for everyone. So we see in the future that this protocol will be used much broader, and that's why we want to enable for the DAI token holders to be a part of that. For instance, by being the time nodes in the setup. So that's what we want to do. There is a question: what is the time bounty? Yeah, so the time bounty is a bounty. So we call it a time bounty here. So this is the bounty that is going to be act as an incentive to the executing agent or the time node. Okay, go on, Eric.
Yeah, so I think right now, Peter, were there any other things that you wanted to cover? Because if not, then let's open it up to some questions, and I'm gonna go also scroll through, see if we answered most of these. And let's go ahead. Let's go through some of these. Gustavo, not at this point. It's still in early stages, so not at this point. Peter, do you want to get Sujit?
Yeah, so I'm basically done. I think that's everything from my side. So yep, let's go into Q&A then. Thank you, Eric.
Okay. Yeah, and Sujit is asking. Yeah, no,
All
no
right.
worries, no worries.
Is the Ether locked into the contract so it cannot be used by anyone? Yes. So when you schedule the transaction, it's locked in the smart contract, so you can no one really can't use it at that time until the execution will happen.
Okay, perfect. And the next level?
Okay, bounty. So yeah, exactly. So the bounty is the maximum fee that you want to incentivize the agents, and obviously the more agents will fight for the transaction, it should go down. It's very similar to the Ethereum Ethereum mining. So if there is if the network is empty, then basically the price of the execution, the gas price is lower than if we have any of congestions and so on. So hopefully that answers your question.
Yeah. And Brendan, we'll cover that on some other session. Okay. And Gustavo, that hasn't been decided just yet. So let's go ahead. Stan, hedging is not would not be possible via some type of, I don't know, let's say oracleized service or anything like that. That's not possible. Okay, so let's go ahead and Peter, just wanted to see if there's anything else that you wanted to cover. I wanted to just do this as a quick 30-minute get together and session to show what you had to cover. I know there's some other things, so wanna keep everyone excited about what is to come, and we can probably do another session, let's say within the next week or so. We will let everyone know when that is. What do you think about that, Peter?
Yeah, I think that sounds perfect. So we honestly now in the middle of our development cycles. So that's why there is basically not too much things to be shown from that part. So we definitely will be able to bring more, fireworks later on. So I'm totally down to that.
Okay. All right. So let's go ahead and what I'm going to do is, let me turn this off.